Part 1. Introduction to Biological Safety Cabinets. Users are always confused on which equipment to select that will best suit their needs, so it is important for them to understand the concept of operations and the difference between the types of equipment. The clean bench, fume hood, isolator, and biological safety cabinet, BSC, are the different types of ventilation equipment used in the laboratory to work with biological agents or chemicals. Clean bench. The clean bench is designed for product protection. It does not protect the environment or personnel and should not be used when working with a biological agent or chemicals. Air is directed across the workspace toward the worker to protect products such as microprocessors. It is not suitable for chemicals or biologicals. It has HEPA filters that circulate air away from the worker. Fume hood. The fume hood is a kind of ventilation system that is designed to protect personnel from volatile toxic chemical vapors and flammable chemicals. The concept is that air is drawn in from the front of the cabinet and expelled outside the building where it is mixed with fresh air. When using a fume hood, a building engineer or a technician should be consulted to ensure that the ventilation system of the existing building is adequate for the installation. Like the clean bench, the fume hood cannot be used for biological agents because there is no system to protect the user from biological hazards and it does not protect the product. Isolator. An isolator is a type of enclosed ventilation system that has physical barriers. Internally, it provides a workspace which is separated from the surrounding environment. There are positive and negative pressure isolators. Positive pressure isolators can be used for the aseptic preparation of pharmaceutical products, while the negative pressure isolators are used to protect the operator from hazardous materials such as cytotoxic preparation. Biological Safety Cabinet, or BSC. The Biological Safety Cabinet, or BSC, is a vented enclosure that is used in laboratories to minimize the exposure of laboratory personnel to aerosols or droplets while they are working with infectious agents and toxins, IAT, or biological select agents and toxins, BSAT. It is important to certify cabinets annually. The BSC contains two major components: the motor blower system, which controls the airflow and compensates for filter loading to provide a constant volumetric flow rate of air. High-efficiency particulate air filters, better known as HEPA filters, which have a minimum particle removal efficiency rate of 99.99% on particles smaller than 0.3 microns, remove bacteria, spores, and viruses. BSCs are designed to provide three types of protection, including product protection, personnel protection, and environmental protection. I will discuss each type separately. Product protection. The downward flow of HEPA-filtered air across the work surface of the cabinet in a single direction at a constant speed or laminar flow. The downward moving airflow splits as it approaches the work surface. The fan draws part of the air to the front grill and the remainder to the rear grill. This split generally occurs about halfway between the front and rear grills above the work surface to prevent cross-contamination. The air drawn through the front grills creates an air curtain to protect the contaminated air from getting into the work area. Personnel protection. Airflow is drawn into the front grill as an air curtain along with the sash provides protection to personnel working in the laboratory. Environmental protection. Because cabinet exhaust air is passed through a certified HEPA filter, the cabinet is particulate-free, providing for environmental protection. Types of BSC. There are three types of biological safety cabinets: Class 1, 2, and 3. I will discuss types 1 and 2. Class 1. BSC Class 1 cabinets have exhaust air that passes through the HEPA filter. They offer personnel and environmental protection from biological agents but do not offer product protection. Class 2. The BSC Class 2 cabinet is the most commonly used for working with biological materials because it can provide all three types of protection: personnel, product, and environmental. BSC Class 2s are classified into 4 subtypes: A1, A2, B1, and B2. BSC Class 2 Type A1 has a minimum inflow air velocity of 75 feet per minute through the front opening, with an exhaust approximately 30% of the total air handled and recirculating to 70% in the cabinet. For cabinets built after 2008, they now come with biological ducts and plenums under negative pressure or surrounded by negative pressure ducts and plenums. Class 2 Type A1 cabinets are not suitable for work with volatile toxic chemicals and radionucleotides. BSC Class 2 Type A2 have a minimum inflow air velocity of 100 feet per minute through the front opening, with an exhaust approximately 30% of the total air handled and recirculated to 70% in the cabinet. There is negative pressure or surrounding negative pressure in the ducts and plenums to contain the biologically contaminated air in order to protect the environment if there are any leaks at the exterior surface of the BSC from IATs or BSAT. The recirculated and downflow air is vented outside through a canopy unit. Therefore, the cabinet can be used with biological agents containing minute quantities of toxic chemicals and trace quantities of radionucleotides without interfering with work. BSC Class 2 Type B1 cabinets have a minimum inflow air velocity of 100 feet per minute through the front opening, with an exhaust approximately 70% and recirculating air of 30%. The exhaust cabinet air must pass through a dedicated duct to the outside through a HEPA filter. Additionally, there is no internal blower for exhaust and air must be vented outside through a hard duct. BSC Class 2 Type B2 cabinets have a minimum inflow air velocity that is 100 feet per minute through the front opening, with no recirculation of the air. There is exhaust of 100% of the air to the outside after filtration through a HEPA filter. There is no internal blower for exhaust and air must be vented outside through a hard duct. This type of cabinet may be used as an adjunct for microbiological studies with biological agents that require treatment with toxic chemicals and radionucleotides. In conclusion, the concept of BSC operations revolves around how the blower works and the efficiency of the HEPA filter. The laboratory supervisor and responsible personnel, including the BSC user, should understand the general principles to operation and proper maintenance of the cabinets. BSC field certification tests must be performed on each cabinet at the time of installation and at least annually or whenever the HEPA filters are changed, maintenance repairs are made to internal parts, or when the cabinets have been moved.